Hello, math champions. Today in this video, we'll learn a little more different types of probabilities or different scenarios of probabilities also. First thing is, let's say single probability. Single probability means what? There's a single event, that is a single thing is happening and you have to find the probability of it. For example, I am throwing a dice, okay? Throwing a dice and I'm going to choose all the numbers which how many times a even number comes. Okay, the event that I'm looking for is even number coming on the dice. Okay, so in this case, what will be the probability? For that, we know probability of any event, okay, any event A is given by what is the number of times of a chosen event comes, okay, chosen event, how many times it comes over the total number of, uh, items in the sample space, Now you need the sample space, isn't it? Sample space means all the different possible outcomes. What are the different possible outcomes when I throw a dice? And it should be a fair dice, I'm saying. What do you mean by fair? Fair means equal share is there. And I'm saying it's a six-sided, six numbers are there, okay? Six numbers are there, like 1, 2, 3, 5, 3, 4, 5, 6, 6. And it's a fair dice. Fair dice means none of the numbers are repeated. There's no partiality. There is no unevenness. Everything is, equal. So totally six faces are there and the numbers possible is, these are the numbers that is possible. So the sample space is, when I'm throwing a dice, I can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. See, the total of six possible six possibilities are there, right? So the total number of possibilities is 6. And the chosen event is even number. So where are the even numbers? Here, here, and here. The total three chances, three possible times that the even number can come. So it's a 3/6. And if I reduce it, if I simplify it, I get a 1/2. So this is called a single probability. That means I'm going to take a single event. Okay, single event I'm going to take and I'm going to find the probability. Now that is done. What if the multiple events? Okay, multiple events means, let me say, successive events. Okay, successive events means what? I'm going to throw a dice, but not once. Throwing a dice two times. Two times I'm going to throw. Okay. Twice, one after the other. I'm not do. There's a difference between throwing two dice together and throwing a dice two times. Now, first, let me talk about throwing dice two times. That means the same fair dice of six numbers. Okay, six numbers. I'm going to throw two times. So the first time I could get a 1, 2, 3, 4, 5, 6. There's a possibility. And the second time also I could get 1, 2, 3, 4, 5, 6. All the possibilities. But now, how do I find out? What is the sample space when I throw a dice two times? Means, okay, what is the possibility that 1 and 1 can come? So that is one combination. 1 and the 2 can come. So 1, 2. Okay. Then 1 and the 3 can come. 1 and the 4. 1, 4. 1, 5. 1, 6. This is one when I have only 1 in the beginning. Now I could have a 2 in the first dice, in the first time when I throw. 2, 1. 2, 2. Right? So it goes on like this. So if you see 3, 1. It goes on like that. Till I get 6, 1. That means the first time I get a 6 and then the second time I get a 1. Then 6, 2. It goes on like this till 6, 6. If you see, this will be my sample space. Sample space. And if you see what are the, how much it could be, 6 in the first row, 6 in the first row, the second row, third row, no. So total number of items will be 36. If you see, I done in a very systematic way, right? So the total number of items, total number of possibilities is 36. And now the event that I'm choosing is both the times both the times I'm getting even number. Both the times, so no, even let's take odd number, okay? Both the times odd number. How do we do this? Just probability of that event is going to be what is my chosen event. Both the times I'm getting odd number. That means 1, 1, 1, 3, 1, 5. Right? In the second one, second row, it will not at all be there. 3, 1, 3, 3, 3, 5. Right? Then 5, 1, 5, 3, 5, 5. So totally I got 9 things that could be both the times I'm getting an odd number. 9 over 36. That'll be a 1/4, right? When I'm reducing it. So this is how we find the probability of successive events. Now, we could do that successive event in one more way as well. One way was to write all the sample space possibilities and just take the event and count the number of events and write it. There's another way of doing it. What is the another way? Is when I'm throwing this dice 2 times, and I'm saying both the times I want an odd number. So the first time odd number, first is an odd number, and then second time odd number, right? So it is an and relationship here. First odd number and second odd number. So let's take just the situation of getting odd number here. What is the probability of getting odd number here? It is 3 over 6. Means 3 odd numbers are there. The total of sample space of 6. That I am getting it from this sample space. Right? Now, and let's say second is also odd number. So what happens? I'm going to take from this sample space again second odd number 3, 6. Now it's an and relationship, right? So we can take this first event, this is successive events we're talking about, means one event after the other. So take the probability of the first event, multiply with the probability of the second event separately, means only the second event. Then when you do, you get 9 over 36, which can be reduced to 1/4. We got the same thing, right? This is a way to do for successive events. Now, let's talk about mutually exclusive events. What do you mean by mutually exclusive events? One of the other videos also I've explained this. Let me explain it again. Okay, mutually exclusive events means, let's say in the same throwing of dice, I choose an event called A, which says less than 4. Okay, less than 4, and another event say B, which is uh, you know greater than 3. Okay, greater than 3. Now if you see greater than 3, okay, if you see these are absolutely opposite, means if a number you take which is less than 3, it can never be greater than, if you take a number less than 4, it can never be greater than 3. And if you take a number which is greater than 3, it can never be lesser than 4, right? In the terms of, I'm talking about throwing in a dice, right? So now these two are mutually exclusive events. That means they are opposite to each other exactly. So here it is not one after the other. It is the same. I'm throwing the dice only once. Throwing dice only once. But the event that I'm choosing is different. So probability of A is less than 4, means they are 1, 2, 3, right? So 3 over 6, which is nothing but 1/2. And for probability of B is what? Greater than 3. That means 4, 5, 6. Total possibilities are 3. I mean, the chosen possibilities are 3. The total are 6. So it's 1/2. Now, mutually exclusive events, what will happen is, when you add the mutually exclusive events, they will be 1/2 plus 1/2 is equal to 1. Right? It's going to be like that. That means if you say you can say one event, let's say take an event which is, I'm choosing a even number. Okay, I'm choosing an even number. And if I take another event, it is not an even number. not even number. What you can do, okay, let's say I'm going to, for this scenario, let me take, instead of just the dice, let me take a pack of cards. Let me take a pack of cards, which is having different numbers, not always same. 6 and 12 and like 8, 17 and 19. Okay, let's say this is a pack of cards which is having these numbers. Now, probability of finding even number and probability of finding it is not an even number. See, here because these two are mutually exclusive, you need not find both. Means if I find the probability of P, okay, even number is 6, 12, and that's it, right? 2 fifth, 2 fifth. Now, because P and Q are mutually exclusive events and the addition of them is going to be 1, you can directly say this is going to be 1 minus 2 fifth. That means it is going to be 3 fifth. And you see, you will also find here these are the odd numbers, not even numbers, not even numbers. And it is 3 fifth you will get. That means even number and not even number. So they are mutually exclusive events, right? So when you find one of the probabilities, then you subtract the probability from one, you will get the probability of the mutually exclusive events value, right? I hope you're clear with this, all these concepts. Go ahead and practice some problems where different scenarios are there and practical applications are there. And then you can be sure you have mastered this concept. I'll see you in the next video with more concepts of mathematics and probability. Until then, see you. Bye-bye. Keep practicing. Always math champions.